Good morning, everybody. Just giving a couple of seconds for everybody to be able to join. For everybody that's joining now, good morning, everybody. Just waiting for a couple of minutes until everybody can join. You'll probably hear me say this a couple of times, and I'll also repeat, if you have any questions throughout the session, you can put it in our Q&A section at the bottom of your screen normally. All right, good morning, everybody. So let's get started with today's session. So today we're going to cover GitLab CI/CD deep dive, advanced session, however you want to call it. It's essentially going to be a deep dive in CI/CD. This session is being recorded, and so for anybody who can't join now, we will be sending it out later on as well. Probably after this session or after the end of the webinar series. That's up to my marketing colleagues to decide. So let's get started. My name is Kristof Goossens. I'm one of the solutions architects at GitLab. I'm based in Belgium. And essentially my job is to, well, try and not bore you for the next hour or so, and try to be informative at the same time as well. So we're going to cover a couple of topics. Going to get started to see whether everybody's going to be covering the same basics. So we're covering the CI/CD basics very quickly. And then we're going to go over a couple of pipeline architectures that we can use as part of GitLab pipelines. Then we're going to go over how to control your jobs and when your jobs are going to run, and assembling pipelines from components, or component reuse, and how to leverage that. I've got a slide demo prepared as well. I'm probably going to switch a couple of times between the demo and the presentation itself, just to show you the relevant case pieces there. And in the end, we'll have a Q&A session as well. But as I already mentioned before, you can leverage the Q&A session as throughout the presentation, and my colleagues will try to answer that, and everything else will be covered in this Q&A session as well. First things first, we'll start with a small poll, which is this one. So what's your biggest security challenge today? So feel free to fill it out. Well, who knows, perhaps there's some surprise afterwards for everybody who joins the poll, but that's, again, not up to me. I'm all about giving, but I'm not about budget whatsoever. All right, I see a couple of answers coming in. Perfect. Let's see the results. So still the bulk of you are making security part of the every dev team's workflow, which is the perfect trend that we're seeing more and more. security for containerized cloud native architectures. That's also something that we encounter a lot. So thank you for the results. Sorry, I didn't click on the share results, so you can actually see the results on your own as well. All right. So let's get started with the CI/CD basics review. So first of all, this is essentially our GitLab Flow, and as Git allows a wide variety of branching strategies and workflows, it might be that a lot of companies end up with a very complex setup essentially of their the workflow, or workflow that is not really well defined and can be misinterpreted throughout the organization. And this is why based on feedback of a lot of our conversations with customers, we have an opinionated flow, which is called the GitLab Flow. The GitLab Flow is essentially a clearly defined set of best practices, which allows for a simplified branching strategy with all features and fixes that go to the main branch or the default branch first, and it allows for production and stable branches to be used. Bug fixes, hot fixes, and patches are cherry-picked from the main branch, and this is something that we recommend for DevOps teams to follow this process while using the GitLab's capabilities within a concurrent development lifecycle. The GitLab application is based around a feature branch-based workflow. It's not the only way how to use GitLab, but this is the best practice that we're promoting as well. And the merge request is there, one of the core capabilities of the product. So the gray line on the bottom, you see that's the default branch or the target branch essentially. And whenever we're creating an issue and starting working on that issue, we're branching away from that to create a merge request and at the same time create a feature branch that goes along with it. Which means that all the commits, all the changes that are being done do not affect anything on the main branch essentially. From there on, the pipeline gets triggered automatically, security scans are being performed, and all the information being gathered is being reported back into the merge request. A review application can be deployed in essentially an ephemeral environment where we're going to deploy a temporarily version of the application that you can use to actually look at, to have some discussions around it. And those discussions together with code and security reviews are also part of the merge request. The approval flow follows that. So you have all the information in that merge request that is required to make a decision essentially and provide your approval or not and continue discussing. And when all approvals are being given, have been given, you can merge it back into the main branch where the CI/CD pipeline kicks in again to deploy it into the next phases of your pipeline. So if we look one level deeper and look at our CI/CD pipeline, you see that it consists of multiple portions. So first of all, after merging the code and finding the related code into the commits, we will trigger the CI pipeline, which will do the typical building and testing of your application. After that, automatically the deployment part will be kicked off and things like the review applications and other environments will get deployed automatically as well. Now, how are we going to get started with that? Is essentially by building a CI/CD pipeline. If we look at the anatomy of a CI/CD build, we see that we have, first of all, the pipeline, which is a number of jobs that are related to each other, optionally organized into stages. The stages itself is a collection of jobs that are going to be run in parallel. And the jobs itself are scripts that can perform some tasks, like the examples there. Environments play a good role here as well, because you're always going to run those jobs against, or you can run those jobs against specific environments as well. Short break already. So it's time for our second poll there. And that's essentially the question, what's your biggest compliance challenge for today? Is it catering to changing regulatory requirements, or do you have too many frameworks that need to be that you need to be managed, or those processes are way too manual, or there is integrations into different tools. I'll give you a couple of seconds to answer. That allows me to get a drink as well. Select a couple of people thinking about it. Can be a tough decision as well. All right, and let's see the results. And you see, it's a mixture of people. At the bulk at the moment is saying that of you are saying that it's two manual processes, which I tend to agree. There's a lot of manual work still there, providing input into the audit process and everything else. Followed by catering to changing regulatory requirements, which is also very challenging. Thank you for answering the poll. So now the first real section of today, which will be the pipeline architectures. I highlighted a couple of pipeline architectures or special cases, you can call it as well, where pipelines are in use. So we start with a very basic one. Then we're going to dive into the directed acyclic graph or the DAG pipelines. Parent-child pipelines, dynamic child lines are tightly related to those, and then multi-project pipeline, and finally the compliance pipelines, which is still a pretty new features. So starting with the basics, a pipeline typically, as already mentioned, has stages and has jobs. The stages will essentially combine the jobs, but the jobs will run independently, even sometimes on different runners, depending on the job definition. All jobs in the stage must complete successfully before proceeding to the next stage. A small note there is that we just released a new functionality. Well, I think it's 2 versions ago, where we allow you to run stageless pipelines as well. So this is becoming optional as long as you're using the need functionality in combination with that. So, but this is how a basic pipeline looks like. It does have a couple of options that weren't highlighted there. So for instance, you can have manual jobs, and what you can see at the right side, which is symbolized by the play button and the gear icon there, which means that somebody actually have to trigger the play button to trigger the job itself, or an API call to trigger that job as well. Some jobs, by default, a job needs to pass before the next stage is going to start. However, there's some overrides that are possible to allow failure, and that would mean that you will get an exclamation icon over here. And also pretty recent feature, you can be very specific in what is allowed to fail and what not. So if you're expecting certain exit codes that are okay, then you can specify them as part of your job description as well. There are still some other options like delayed that you're going to wait for a while on failure. So for instance, for cleanup jobs, if something happens and there's a failure, that you can actually clean up the environment that you just spun up, for instance, as an example. And jobs that will always run, no matter what the success status is. The second portion is the directed acyclic graphs, so the DAG visualizations, which is essentially visualizing the needs relationship in between the jobs. So for instance, to speed up your pipeline, it does not make sense that all the Android tests have to wait until the iOS build has been completed. it makes much more sense that it just waits until the Android build is completed and then the Android tests are being launched. This is something that we can do by using the needs keyword. However, it's not always visually well usable, or at least somewhat confusing to see the lines in between these jobs. And so we can now visualize it slightly differently. Needs, by the way, can also be optional. So for instance, if you want to run something, if a previous job is there, you're going to need and wait for it. If that job does not exist because of specific rules or specific reasons, then you still are capable of running that job, which would typically normally fail your pipeline if you don't have that optional keyword there. So how are we visualizing it? It's by using the DAG visualization, which is a very nice and colorful way of visualizing the flow of dependencies, essentially. So you see here at the left side the first job that needs to be completed, and when that is completed, the next jobs can be done as well. And eventually, until you get to this job, you have to have all of these jobs completed together as well. Now, GitLab is all about iteration, and iteration means getting feedback from our customers and our users, essentially. Which were essentially saying it's very nice feature to visualize it, but not really useful because we need to swap between tabs all of the time to see the actual status of those jobs as well. So we listened and we introduced the job dependency view as part of the pipeline view. So now if you go to the pipeline view, you have the possibility to click on job dependencies and to highlight the job dependencies as part of your pipeline. You'll see that the stages are left off because this view will show you the hierarchy based on the dependencies and not based on which stages that they're part of itself. All right. To get to this, well, it's still only a needs keyword that is needed essentially, and you used to have a limitation that you have to have at least 3 needs before the visualization comes up in the DAG visualization. This is not the case in the job dependency view, and it's no longer the case in the DAG view either. All right. Another use case that you might have is that you have in the same repository multiple components or multiple parts that can be built independently. For that use case and a couple of others, we have introduced child-parent pipelines, or you can use child-parent pipelines, which based on an event, a trigger keyword, essentially, you're going to run one pipeline or the other, or multiple pipelines combined. This is essentially being visualized like this. So you will have a downstream pipeline that is being triggered. So whenever, in this example, the pipeline itself, there was a change in microservices A, B, and C, these will trigger their own child pipelines based on that change. And that will be visualized in the downstream job, which will then show, if you click on it, all the different jobs that are part of that child pipeline. A particular use case is for monorepositories, for instance, where you have the multiple and all components of your monorepo as part of the same repository, hence the monorepo. And there it's very useful to actually define it your pipeline as part of your folder or subfolder that you have in your repository, and you can essentially depend on that on the run of that pipeline as well, which means that you're going to wait until the pipeline finishes before continue this pipeline. You see that there's a nice remark over here, only except. So this example still uses the only and except statements. This is being phased out, and we'll see in one of the next sections how we're now doing that by using the rules keyword as well. but the main principle remains the same. Another use case there is sometimes, depending on what kind of build that you want to do, you need to generate a second portion of the pipeline, or a portion of the pipeline, because you depend on, I don't know, the generation of a set of files, or whatever reason that there is. We do support that by using dynamic child pipelines, which means that we're going to always have a two-phase approach. First one will be the setup phase, where you're going to run the scripts or do anything, call an external API, any way that you want it to run, to actually generate the configuration that you'll need to run in a later phase. That portion will then be saved as part of an artifact. You'll see here a very simple example that we have a test GitLab CI, which just has the replace me words over here, which actually is being replaced in this very simple script. But this can essentially be run or be generated by any script that you have, for instance, a template model or whatever you want to use it. So that script that generated is then being saved as an artifact, and that artifact is being used in the next stage, the next job, in the next stage. It picks up that artifact from the setup job over here, and then it's actually going to run it. If you look at how it looks in GitLab, it's pretty much the same as it's a child pipeline. However, the unit tests and the integration test jobs were generated, which means that if you look at the results for that job, you'll see that the placeholder was replaced, and that's actually the values that we are running. So essentially, the generated pipeline is being triggered and being run over here as well. Multi-project pipelines. So the opposite of monorepos is by using, for instance, microservices. Obviously, you can have anything in between as well. But with microservices, you're going to save your modules or part of your applications, services of your application in separate repositories, essentially, and each repository can contain its own pipeline definition. By leveraging multi-project pipelines, you can trigger one single build or one single pipeline that will pick up and execute all the different pipelines of the related project as well. That's one use case for multi-project pipelines. Another one is if you separate your application out into the actual development environment or the development repository, and next to that a deploy repository, because that's another team, or it's a subset of the team that has other level of credentials or other level of permissions in that project. That's also a possibility here, and that's essentially what I'll show you in a moment in the demo as well. Visually speaking, you'll see that multi-project pipelines is also using downstream jobs, but instead of highlighting that it's a child pipeline, it's actually an actual downstream job coming from another pipeline running in another project. Then we are arriving at the compliance frameworks, essentially. So in the compliance frameworks is a functionality that we are supporting in GitLab, and it allows you to identify each project, whether it needs to be compliant against a specific framework. The framework on its own is essentially up to you. This example, I used GDPR, but it can be, Acme framework, or Christine framework, or Serena's framework, whatever framework that you want. The goal here is that you can, as part of the definition of that framework, you can also define the mandatory pipelines that needs to be, or jobs that need to be run in the pipeline for every project that needs to be compliant against that with that framework. Which means that you can have a centralized way of defining the mandatory jobs and the pipeline stages, and essentially force that on or make sure that your projects are compliant and always running that job. This is essentially an example, but I think it might be more interesting if I just switch into my demo screen over here. And while I'm doing that, feel free to raise any questions in the Q&A section in the bottom of your screen. So if everything goes well, you should be seeing my demo project over here. And so we have seen a couple of things, and it might be potentially too much in one go. So I'll try to repeat a couple of things. I prepared a couple of merge requests just to run through as well. And what we can do is we'll start out with a very basic, one, which is essentially a bash script. And as with everything, I'll quickly open up the IDE, do a change, which will trigger our pipeline. Oh, the wrong view. So let me go with README. A very important change. And this change will essentially trigger our pipeline. Now, what kind of pipeline did we set up in this case? We essentially, this is the example of the DAG pipeline. So meaning we have an iOS build, we have an Android build, and we have set up our iOS test and Android test to need or to wait and depend on the build jobs itself. So if I quickly go to that pipeline, you'll see that because I've done a change, this pipeline is being triggered. Now, where are these pre-compliance, pre-deploy compliance, and post-compliance things are coming from? Well, that's the last one that we just explained. So if I go to my GDPR, if I go to my project, I see that it needs to be GDPR compliant. And GDPR compliant means that we have it set up to run a specific set of pipelines. If I go to my top level group, I can show you how it was set up. And I'll open up the compliance frameworks project at the same time as well. So here we have a list of my top level group of the compliance frameworks. Oh, yeah. I can add any framework essentially. I'll just edit the GDPR one, where I'm just going to have a description of what this framework is. So the title, the general description itself, and then we're going to configure a specific YAML file that will contain all the different jobs that we will be running. The format being used here is essentially the file name, and then the hierarchy where the project belongs to. So in my case, it's my group, compliance and compliance frameworks, and there we should see the GDPR file. So if I go back to my project, you'll see that we're in my group, compliance frameworks, and here is the file that we're talking about. So if I open this up, it's essentially the same type of YAML file, so we can apply any pipeline configuration over here. We have defined the stages just to make sure that the order is the one that we're expecting. Some variables here, and then we have defined all the different portions of our audit that it needs to be done. And then we're essentially including the rest of our pipeline over there, which makes us end up with, well, essentially the pipeline that I just forgot where it was. Over here, I guess. this one, which will show us all the different sections, including the compliance one. If I now go into my, well, actually, I could have done that here in my project itself. And in this case, I'm the owner of the project, so I can change my compliance framework. And I'll be saying here that we don't need to be compliant anymore. If I could go back in my exactly the same project. Do a crucial change to my code and commit. We will see that, well, once a runner has picked up the job, that the pipeline has been triggered. And we will see that it's way easier than before. Well, easier. It's more logical than what we were expecting, because our compliance pipelines are no longer active here, which means that only the local GitLab CI file is being taken into account. So while we're on this page here, I did mention that there's now a needs tab, which is the DAG visualization that is now be visualized without having 3 needs already, which is in this case an example of that. And we do have a job dependencies tab here, which will show you the dependencies. Pretty straightforward in this case, but in other cases it might not be that straightforward to see. All right. We're quickly going over the parent-child pipeline example. And even in the merge request, as mentioned in the beginning, the merge request will gather all the information. So you have a single source of truth for this particular change. Even in the merge request, we'll see that there is something special in the pipeline here, because there was a child pipeline or a downstream job being defined. You'll see that in the minimalistic view here by the arrow that you have there. And as mentioned during the presentation, we are essentially, well, defining our pipeline itself, defining a trigger job, and the trigger job will essentially trigger the downstream pipeline that is being marked as child. If I open it up, I can actually see what the statuses were of this, or I can go in the actual pipeline run for this, which will highlight that it's a child pipeline, give me a link back to my parent pipeline, the same over here. And just like any pipeline, you can start working and looking into these different jobs as well. All right. As mentioned, feel free to ask any questions in the chat. Sorry, in the Q&A session. It's polling time. Last poll for the day. How many hours per week do you spend addressing compliance issue? All right, I guess it will also depend which week you are. Whenever there's an audit or not, might tend to change, obviously. Give it a couple of more seconds. Right, going once, twice. Let's see the results. So most of you that answered are essentially spending less than 4 hours, which is great. But know that even half an hour on a weekly basis adds up a lot on an annual basis as well. Anyway, thank you for participating in the polls. You rule. Anyway, rule section. So essentially, when our pipelines are going to be executed. So there's multiple ways to define when a pipeline needs to be executed. Can be, as mentioned at the top, on a new commit, a new branch, a new tag, or manual by actually launching it by yourself, an API call, by some integration that is being set up with the release management process or whatever process that is being used in the company, or scheduled on a regular basis. For instance, if you want to do some cleanup or some scans, security scans on a regular basis of your project. So that's all of these can be set with rules, but you always have to pay attention, because if it's not set correctly, it can get weird, because in this case, it's the same commit that we're using, but it did trigger 2 different branches. Well, it's probably going to be one for branch and one for the merge request itself. There's a couple of ways to get around this, and one of them is by using our templates, essentially, or rules templates, which are, I think I've briefly shown it for if you're paying attention in the source code in the previous demo, but I highlight it in a moment as well. So some basic rules, or the rules basics in this case. You have the job name as usual as the definition of within your pipeline, and then you have the new rules block and keyword that is being used. As part of that rules keyword, we're going to use some if statements, essentially, or using some variables, potentially predefined ones, in this case, where we're going to define when it's going to be run, or when it's not going to be run. This is essentially replacing the only except statements. So essentially, only and except was a very nice way to define when a specific job needed to be run, or when it couldn't run. The rule statements are replacing that and are much more flexible. The reason for that is because we have multiple portions that we can combine together. First of all, we have the different clauses, so the if clauses, change clauses when it exists, or nothing at all. The operators, whether it's need to be equal, like, whether it contains, can be used, and on results. So like when manual, for instance, or when delayed, it will specify the different when options, which you see in the last column there as well. A combination of all of these essentially is going to is possible to add to the rules keywords, and they're going to be processed from top to bottom, meaning that if something matches, we're going to stop by processing the rules. If nothing matches, we continue until something matches. If not, the default rule will be applied. Mirko, you're jumping the gun for a moment. It's coming. Good point. So a quick reference there is essentially, so if no attributes are defined, the default is when on access, and allow failure is false. So meaning every job needs to be successful, or not, it will fail, and it's only going to run on success. When the job is only added to the pipeline if the rule matches and has when on success, when delayed, or when always, that is being defined. Or if no rules matches, but the last clause is when on success, when delayed, or when always, with no rules attached, which means that, that will be applied. On the other hand, it's not being added to the pipeline if nothing matches, and there is no standalone when clause like before, or if a rule matches and has the when never as an attribute. So let's go into a couple of examples. So in this case, essentially, we're going to look at one of the built-in variables, which is the CI pipeline source. So we can define that specific jobs will be run when coming from one source, and other jobs can run on another source. So in this case, in this example, we're only going to run when it's a merge request event and or when it's a scheduled event as well. The second portion essentially is when it's well, this is essentially the opposite of the previous one. So it's going to run always, with the exception of when it's a merge request event and when it's a scheduled event, because we have defined the never. So when essentially it reads like that if this is true, then we're not going to do it. You never run it. The same goes for the schedule. You're never going to run it. But the last one is a when on success without a condition attached to it, which means that if the previous two did not match, it's still going to run. Third example is essentially by using a custom variable. So variable that can be set as part of the CI/CD variables UI by the API, or as part of your GitLab CI YAML file. So in this case, if something is false, your variable is false, it's not going to run this job. If that does not exist or is true, then it will always run. And a point here, it actually is always going to run. So even if there's a failure, it's still going to run there. For example, here is slightly more advanced-ish. It's going to run the script whenever the variable is equals to the string value. So literally string value in this case. And when there was changes with to the Docker file or to any file as part of that folder, and we're going to put it as a manual job. If this does not apply, then we're just not going to run the job. Almost the last rule example. So if in this case we're on the main branch, in this case it's literally the master branch. We can use the default branch parameter here as well to be a bit more flexible when you change your default name. And it's going to run. However, it's going to run delayed by 3 hours. So it means that the run will be the job will be triggered after 3 hours of waiting. If not, it's not going to run whatsoever. And the last example over here is essentially whenever the git ref name contains this keyword, so -WIP, it's not running. If it's a git commit tag, it's not going to run. And in all other cases, even on failure, it's going to run. Right, so a couple of examples there. Mirko will still have to wait a bit for his answer to it, because it's essentially after the includes. So to start reusing all of these configuration, we can use the include keyword in multiple ways. So essentially, it allows us to break down the configuration of the YAML files in multiple pieces, and then include it in the same project or in external projects there as well. We have multiple ways of doing that. So include just without anything, it's going to look for a local file, essentially, which is essentially the same as using the local file. You can use the file keyword, which then allows you to specify which project it's coming from. You can use the remote keyword, which is essentially going to use an HTTP request to get that definition. And that can be hosted wherever you want. So as long as it's a web server somewhere that can be reached, you can include it from a remote location. And the last one is typically the first one that you see when starting to work with includes, which are the templates. And the reason why we're typically starting with templates is because there's a set of templates that already are created by the GitLab engineers that you can leverage from. However, you can say that you can create those templates on your own, located in a specific centralized folder, which will optimize all the creation of your pipeline. Let's say, for instance, you have a very specific way of building your application. You can make it create it once, and then include it in all the other projects that are using a similar approach. And now we can also include with rules. So essentially having a conditional include what I believe this was the one that Mirko was referring to. So we can specify within our definition whenever a specific rule applies that we're going to include another part of the definition, which makes it a very dynamic way of well, essentially to dynamically modify itself based on the chosen conditions itself, which is yet another step of being even more powerful. The extends keyword can be leveraged from. So essentially, whenever you have a job, and in this case, there's a hidden job because it's any job that starts with a dot is a job that will not be executed on its own, but it can, in this case, be leveraged to extend from. So in this case, our RSpec here extends from tests, which means we'll get all the different values coming from the .tests job definition. However, we're adding the script and overriding the only variables there, but there is no variables here, so we're essentially adding it to the definition that was already there. We can combine the two. So if you have a template somewhere which is included from another file, you can still extend it as well, which makes it even easier to build a nicely formatted pipeline definition. In this case, you could have multiple jobs based on the same template, just using other names or extending the job that you're well basing your template on. Pretty recently, we essentially added the reference keywords, or the bang reference keyword, which is essentially a similar approach to what used to be the YAML anchors. However, a YAML anchor means that you could only use a YAML anchor as part of the same YAML file. So if you're including a file, the YAML anchors couldn't be leveraged, and now this is possible with the bang reference definition. It's essentially going to refer to a portion of a definition. So in this case, same thing as before. We have a hidden setup job and a hidden teardown job. In this case here, we're going to refer to the setup job, and we're referring to the script section of the setup job. This allows us to, well, pick up that script section and add on top of it. With extends, it's not possible because if you have, in this case, the same example, and I would extend from this setup job, and then have a script section over here, this echo creating an environment will never be executed unless I put it in my script section here as well. So in this case, it's a more flexible way of adding on top of the definition that you have. You can, for instance, have multiple template jobs and then referring to multiple portions in your script as well. Newly added is essentially the same functionality, but as part of your rules. So if you have a default set of rules that are being set up, now you can refer to it by using the bang reference portion as well. By the way, I didn't mention it here. I forgot to add it to the slide, but there's a third level that can be possible as well. So suppose that you have a job, default rules, and in default in default rules, you have a variable section. In the variable, you have a specific variable that you want to leverage from. Then you can still add a comma and the name of the variable there, and only pick up that variable name versus picking up everything. All right, so if my clock works correctly, we still have 10 minutes left. I'll check the Q&A first. And Martin is asking, why can't we have several pipelines per project? The presented solutions feels more like a workaround. Well, we do have multiple pipelines per project, but we're always going to start with the .GitLab CI YAML file, and then including other portions over there. Why is it like that? It's well, I guess it's a design decision that was taken. But yeah, if there's something missing that you can't seem to do with this setup, I'm happy to pick it up and to see whether we can add something more of a functionality there. For now, indeed, the way how you could do this is essentially having a pipeline definition. For instance, if you have a monorepo by the folder, a subfolder, and then include the part that you want to run based on a rule, essentially. If it's a changes as part of the hierarchy and the likes, a typical question related to that would be, well, what about blocking the permissions? And we can be very specific in that as well, because you can essentially set up the code owner file that CI or that YAML definition essentially, or that file as part of that YAML definition as part of the folder potentially is linked to a specific group that need to be approving before a change happens, or a person in the team that needs to approve it. I hope that answers your question. If not, feel free to add on top of it. All right, on top of, so we have different products in one repository that share different parts. This will make it really complicated with the rules. Yeah, in this case, typically you have a dependency file somewhere, or dependency definition somewhere. Might be possible to leverage the generated pipeline, so that you essentially generate this based on the script, based on parsing the dependencies, that you're going to generate the definition there as well. And as part of that definition, the rules can be as part of that as well. You're welcome. And again, happy to help out on that, or to relay to my colleague, depending on which customer you're from. It seems that we're all part of the same team. It shouldn't be a problem. So yeah, if there are any other questions, feel free. I've got a Q and hopefully a section foreseen here as well. So if there's any hands, yeah. So Martin's asking, is it planned to extend the templates for the CI parts? So missing Helm examples. You mean the template examples? There should be a couple of them in the talks, if I'm not mistaken, but I'll have to look that up, unless if somebody knows that. I see Mirko and William are here as well, so potentially they have some nice input for that. Yeah. All right, and so the last thing from Martin is, in general, as a feedback, I would have expected way more boilerplates there. This is actually something that is part of the verify stage vision that we're doing. There's some iterations already there now. So we have had some feedback from customers that it's not that obvious to get started with the GitLab CI YAML. And now, as one of the first iterations, you're getting a sidebar with some more information and being more directed towards those examples. But there's more iterations coming up around that. I can see normally in our handbook page for the verify stage, we have a 3-year vision. I believe it's even a video that is being added there, which will show the direction essentially. And it's with everything. Very happy to have feedback on that. And I'll see whether there is. Yeah, I'll do the full direction page in the chat. But there's a lot of links over there as well that you can follow. Yeah, indeed. So it's another approach. It's more a catalog approach that GitHub is taking as well. There's pro and cons on both sides. I've heard from customers that it's sometimes not that easy if you want to combine a couple of those actions as well. Again, heard it, didn't try it yet. I know that having good documentation helps, and making that documentation way more visible is essentially the first approach. But we're iterating over it, and as I mentioned, happy to get more feedback around that. I believe it's part of the pipeline authoring group that is essentially looking at that more in depth. All right. Any other questions? If not, yeah, that's right, Mirko. So the Auto DevOps feature is essentially helping out in setting up the first pipelines essentially, and can leverage even portions of Auto DevOps from there as well, and look at those. There are the deploy or the review portions of the Auto DevOps pipeline is using Helm charts as well. So that might be also something. All right. So if no other questions there, and somebody give me a yell if I'm not seeing a question, obviously. The last thing that I want to do is thank you for well, making it to the end, I guess, of the session, and to actually be here as well. We do have 2 more sessions on October 12th and October 26th, where my colleagues are going to talk about the Open DevOps platform deep dive and GitOps deep dive as well. All right, so thank you, everybody. Have a great day and the rest of the week, obviously, and hopefully see you all on the 12th of October.